Okay, let's get into section 3.1. So with 3.1, I'm going to start something different. I'm going to highlight my notes that I would typically use in class. Now, the glory of the Zoom deal here is that you can pause this anytime you want and look back over or read my comments. So I'll keep this part quick. So 3.1 is talking about graphing. That's it. They say paired data. Well, that means now we're dealing with an X and a Y. Every time you see parentheses with two numbers written like this, think of it as X and Y, your two values. And then you plug that, that's 1 point. That paired data is a point. So you want to plot that in your rectangular coordinate system or on the graph. Rectangular coordinate system, just as a refresher, it's the X axis is our number line. So negative values moving left, 0 in the middle, positive moving right. Flip it 180, and you have the number line up and down, negative going down, positive going up for the y-axis. Okay, I skip example 1 and 2 because you're literally just plotting points, and at this point, I really hope you can do that. That's the simplest part of graphing. And graph the equation, example 3. The glory, whenever you are asked to graph an equation, you get to choose points. Doesn't matter what they are. When you are graphing a straight line, you are dealing with infinity. So you have an infinite amount of possibilities. Just start choosing them. What I do when there's a fraction, I know a lot of you dislike fractions. When there's a fraction, obviously first I use 0 no matter what, just to see what happens. 0 it out, make it go away. But after that, I'll use something that the denominator divides into evenly, because then I don't have a fraction anymore. I don't want to graph a fraction. I want to graph a whole number. So here, when you're graphing an equation, just choose points. You have freedom. Some people don't understand that. They want rules with math, and the freedom throws them off. Other people really like chapter 3 because of the freedom. They know they get to just choose some points and throw them in there, and they can plot those. So in blue are the points I chose. I chose 0 because it makes it go away. When I plug 0 in for X, it's gone. The result is Y equals 0. So I plug -3 in because that'll give me a positive. 3 goes into 3 one time. So I'm canceling out my negatives, and I'm making it a positive 1. 3 goes into -3, -1 times, -1 times -1, positive 1. Then I'm going to plug in a 3 because that makes the denominator go away as well. So plug in a 3, 3 goes into 3 once, times -1, -1. There's my points. When I plot those, I connect them with a line that goes -infinity to infinity. And this line represents this equation. Any point on this line, I'll say no matter what X value I plug in, I will get the resulting Y that falls on this line. Okay, so down here, they talk translations. What that means is you take a typical equation, and if you add to it, you move up. If you subtract, you move down. That's it. Here is the initial equation. When I add a +2, but I don't change this at all, this is my slope. We'll talk about that later. Then I move every point up 2. So whichever 3, you didn't even have, you could have gone 6 and -6 and 6 because that would have canceled out. But anyway, whichever points you chose, you would move. If it says +2, move each point up 2. When it says -4, then you start with your original and move each point down 4 and connect them. So once you get used to translations, you graph the initial if you want to. You can graph the initial and then literally just count. You can always plug points back in like this and check. But once you plug your points in and check, you can follow them right along and see, oh yeah, it went up 2, it went up 2, it went up 2. Got it. Here, it went down 4, it went down 4, and it went down 4. Yep, true. So either way, if you don't like translations, if they ask you something like this, you can still plug your points in and just graph the line. But translations, that's what it means. The same rule applies to parabolas. Then intercepts we'll talk about. Intercept just means where does the line cross the X and Y axes. Those are the intercepts. So you make zeros. Here you can read through the example. This is me working out example 10 and 11 from the book. If you want to, you can look at what I did and pause it. Horizontal and vertical lines, super duper easy. Simple. Don't overanalyze. They look goofy because they're different. X equals 3. People want a whole equation to solve. There's nothing to solve. X equals 3. Find 3. I should have drawn, well, I'll leave it off. Find 3. 1, 2, 3. There's my X equals 3. That's my line. So it's a vertical line. If it's Y, it's a horizontal line. Y equals -2. Find where Y is -2, -1, negative, there it is, Y is -2. So that's a horizontal line. So don't let it throw you off when you don't see an actual equation. Okay, that was the notes. Now let me jump into some examples to help you with the homework. Now, you'll see where I started that I actually made an entire video, got to this point, and I had written equals 5 instead of 15. So always go back and check your initial problem that you write down, because that's what I screwed it up. Had to do the whole video over again because I was mumbling and made a mistake down here. So 3x minus 5y equals 15, and number 6 is asking which table represents this. They give you all the data points. So I'm just going to use the ones they give and plug them in and see which ones work until I get one that doesn't work, basically to eliminate a table. So first off, all 3 tables have x equals 0. So I'm going to plug in 0. And when I do, my x goes away. I'm left with -5y equals 15. So y equals -3. When x is 0, y is -3. That's 5. That doesn't work. 0, -3, 0, -3. Both of these work. Now the next step that I see, now I know I'm dealing with just these 2 tables. I have a y is a 0, a y equals 0, and then different x values. So I am going to go ahead and make y 0, and then that will tell me which one is my table. So when I make y 0, I'll leave it over here. I am eliminating y entirely. And I would divide by 3. I'm not doing the simple math all out. I'm shortcutting it. So I would divide by 3 and get x equals 5. So here's my +5. This is a -5. That's the only table that works. I don't have to check that next one. I checked my intercepts. Here is my y-intercept. Here is my x-intercept, because it crosses x at 5, x-intercept. Crosses y at -3, y-intercept. I just found my intercepts. Now number 8, and then I'm going to run out of room here. Number 8, the graph shows which equation. So they give us a graph. Now here it moves through like 2.5. But here we pretty clearly see that that's the x-intercept of 4, 0. So that gives me something to go by. So what I am going to do is see which one of these works out if my y is 0. When y is 0, x should be 4. So I'm going to see if I can at least eliminate 1. So 3x minus 0 equals 8. 2x minus 0 equals 8. And 2x minus 0, or plus, I'll say, plus 0 equals 8. So here, I already know that's going to be 8/3. So that doesn't work. Both of these divide out and give me x equals 4. So I've eliminated a. Now I'm down to one of these that's going to work. What I'm going to do is plug 0 in for x and see which one's a possibility. I have a positive and a negative, so I'm going to have 2 complete opposite answers. Only one of them will work. You should know which one already, but what I'm going to do is go down here and I'm going to take b and I'm going to say, what happens if x is 0? That'll give me my y-intercept. When x is 0, and you really only have to do it once, because you'll see that this results in y equals a negative 8/3. To be a negative 8/3, I'd have to be down here somewhere. I automatically know that one doesn't work. So I cross B off. My answer has to be C. If you plug it in, if you plug 0 in, you will see that you have 3y equals 8 divided by 3, y is 8/3. That's what that is right up there, 2.5 roughly. So we've solved which line it is, which equation. Now, number 14 down here, apparently I'm going to have to tear this out so that you can see it. Number 14, graph using the same coordinate plane. So here you go. Some people don't like graphing, other people love it. Graphing, pretty simple. Just choose points. Y equals 1/3 x. If I make x 0, then my y is 0. I know that goes through the origin. If I make x a -3, I'm doing this so it goes away. -3, 3 goes into -3, -1 time, I'm left with a -1 for y. So -1, 2, 3, -1. And then I'm going to choose a +3. When I choose +3, 3 goes into 3 one time, times 1 is 1. I'm left with 1. So when I go 1, 2, 3, I go up 1. There's my initial. On your homework, I don't care how legible, well, even on the test, just make sure you label your points on the test. Show me your points or list them here so that I can see that you graphed it correctly. So next one, I know that I can solve this whole thing if I want to, or it's 1/3 x, 1/3 x. That's the same. It's this line. I'm just dealing with it differently. What happens is they're adding 1. I'm talking about a translation. So I'm going to translate this 1. This was -1. So if I go up 1, it says +1. If I go up 1, I'm to 0. I was 0 here. If I go up 1, I'm at 1. And I was 1 here. And boy, my hash marks weren't too great, but I technically at 2. I'd go from 1 to 2 and then connect those and pretend that they were in a nice line. There's my 1/3 x plus 1. This was my 1/3 x. Now, -3. So I'm subtracting 3. So I was at -1 here. Boy, my dots are struggling. My points are struggling. I'll use graphing paper from here on out, I promise. So I was at 1 here, and I'm just going to move down 1, 2, 3. If you use graphing paper, it'll look better. I was at 0 here, so I go 3, and I was at 1 here, so I go 1, 2, 3. And I didn't have to do any math. I just had to count my points. 1/3 x minus 3. I just had to count my points. If you don't like that, because some people don't, kind of like when we get to rise and run, if you don't like that, you can go ahead and start plugging points in. If I plug 0 in for x, well, now I'm left with 1 here. I still want to get rid of the denominator. So if I plug a -3 in, I'll have a -1. But -1 plus 1 is 0. So I get a 0 there. And then when I go with 3, I'll have 3 goes into 3 once, times 1 is 1, plus 1 is 2. And you can plug those in. Okay, so we could do the same thing here, but we really don't want to. $27. I think that, yeah, 27 is the last one I want to do. I know this video is lasting a little while, but I wanted to introduce the graphing. So find intercepts and use them to graph. This is a concept you will use all throughout graphing. anytime you have to graph, I believe the easiest route is to find intercepts. And because when you are talking intercepts, you are talking zeros. So find the intercepts. Now, typically one is much easier to find than the other. Here, the y-intercept's super easy to find. So I'll just write y-intercept down. To find the y-intercept, we want a value of y. That's what y-intercept means. I used to mix them up a little bit because y-intercept, I would a lot of times accidentally plug a 0 in for y. Y-intercept means where it crosses y. So I'm dealing with a 0 for x. So I have y equals 1/2 0 plus 1. The result is 1. That will 0 out. I'm left with 1. So my y-intercept is 0, 1. Well, for x-intercept, it's going to be a little, well, I'll write it out. X-intercept, it's going to be a little messier because I need an x value and a 0y. So for a 0y, I'm just going to skip that step. I'm just going to say y is 0 equals 1/2 x plus 1. So I just replaced y with 0. When I do that, I am now going to subtract 1 from each side. And I need to solve for x. To solve for x, I need to multiply by 2. When I multiply by 2, 2 goes into 2 one time. That's going to leave me with 1. I need to multiply this by 2. And then I get x is -2. I needed to get rid of my 1/2 x. So to get rid of the 2 on the denominator, that's why I multiplied by 2. 2 goes into 2 once. They eliminate, leaves me with 1x. I have to do that on this side. 2 times -1 is -2. So my x-intercept then, I'll just write it up here. You know where I'm going. -2, 0. I found my intercept. I'm not going to graph it, but to graph it, you know that you will start here at 0 and go up 1. There's where it crosses the y-axis. Then over here, you'll go over -2 and plot it because that's where it crosses the x-axis. Hopefully I said that right, y and x. So there's your 2 intercepts. Connect those. They're far enough apart. Like I said, typically you really only need 2 points to get a good feel for your graph, but occasionally they're so close it's tough to get. So you'll want either 3 points or choose an x value that's farther away. Okay, that was 3.1. We'll be back at it with 3.2 shortly.